We're going to talk about expected value. Expected value is kind of like a weighted average, where what you're trying to do is you're trying to figure out, on average, if you did some kind of activity, some trial, many, many, many times, then on average, how much do you expect to win or lose per trial? Okay, so usually expected value, it's useful to look at with games. So for example, let's say that we play a dice game. Okay, and let's say that you have to pay $50 to play the game. And after you pay $50, we're going to roll a 6-sided die. If you get a 6, you win $100. And you get your 50 back. If you roll a 2 or a 4, then you win $10. And you still get your $50 back. If you get an odd roll, so a 1, 3, or a 5, then you get nothing, including you do not get any of your money back. Okay? So then the question that we can ask is, what's the expected value of this game? On average, per roll, how much do I expect to win or lose? So the way that we can kind of do this, you could probably figure this out even without having done this video yet, where you can kind of try to logic through how you would do this. So I'm going to list all the possible numbers I can roll, and I'm going to list the amount that I win. So if I roll a 1, I lose $50 because I've paid $50 to play, and I don't get anything back. If I roll a 2, I win $10 because I get my initial 50 back, and then I get 10 more than I started with. If I roll a 3, I lose $50. If I roll a 4, I win $10. A 5 being odd is going to be the same as 1 and 3, which is going to be a loss of $50. And a 6 is going to be a win of $100. So if I said, okay, then what's the expected value of this? What I can do is I can say, well, let me add up all of these values. And if I do that, I get negative $30. And if I take all the different possibilities and I divide them by the number of rolls, so I do negative $30 divided by 5, right? I've summed up all of the possible outcomes, and I've divided by all of the number of possible outcomes I can have, I get negative $5. Okay, so this means on average, I expect to lose about $5 per roll. And this kind of leads us to our expected value equation, okay? Because I'm just going to rewrite this in a more suggestive way. So I'm going to say that the expected value of this experiment was we did negative 50 plus 10 minus 50 plus 10 minus 50 plus 100. And we took that and we divided it by 6 because that's the total number of outcomes. And now I'm going to rewrite this as I have 3 ways of getting negative $50. I have 2 ways of getting $10. And I have 1 way of getting $100. And still divided by 6. And then I can rewrite this and say, okay, well, if I split this denominator among all 3, I have 3/6 times negative $50 plus 2/6 times $10 plus 1/6 times $100. And well, why have I done this? Because what I've done is each of these sums contains the probability of one of the outcomes occurring multiplied by the payout, or the amount that I win or lose when that outcome does occur. And this brings me to my equation for expected value. So the equation for expected value, get rid of that, which we can say is EV. You could also see it written as like something like, the expected value. You can have these triangle kind of bars of some outcomes. So the expected value of winning some money or something like that. You see a couple different notations. I'll usually just use EV just because I think it's pretty clear what I mean. So the expected value is going to be equal to the sum. So this symbol, you might not have seen it before. It's a capital Greek letter sigma, and we use it just to mean the sum. So from K to N, So what this is you start with 1, and then you keep increasing by 1 each time until you reach n of the probability of the kth outcome times the payout of getting k. So in our case with the dice rolling game, we looked and said, okay, well, how many different outcomes are there? There were really just 3 different outcomes, right? I could either lose $50, win $10, or win $100. So I looked and said, okay, let's say that outcome number 1 is that I lose $50. So I said, what's the probability of outcome 1 times the payout of outcome 1? Then I said, let's add that to the probability of outcome 2, which maybe is losing $50, times the payout of outcome 2. And then finally, we do plus outcome 3. So outcome 3 is going to be $100. So I did the probability of getting $100, the probability of outcome 3, times the payout of 3. And then we ended up with what we had. We said, well, the probability of losing 50 is 3 out of 6 times the payout is negative 50. Then we did plus the probability of outcome 2 is winning $10. So I have the probability of that happening is 2 out of 6 times $10. And then finally, I have a 1 in 6 chance of outcome 3, which is winning $100, and the payout for that is $100. Okay, so that's what this sum means, is that basically you plug in 1, and then you plug in 2, and then you plug in 3. So for our case, the EV for this would have been the sum from k equals 1 to 3, because I have 3 different outcomes. So n is just the number of different outcomes that you have. Okay, so every time what you're doing is you're finding the probability of each outcome and multiplying that by the payout that each outcome generates. So let's look at another example and try to build some intuition for how this works. Let's say that you are going to do a basketball toss. So a basketball toss, let's say it costs $5 to play. 5 to play. And you get 3 tosses, okay? So if you get 0 baskets, then you get nothing. If you get 1 basket, then you win 50 cents. If you get 2 baskets, you win $6. And 3 baskets, you win $25. And this is not in addition to giving you your money back. There's no money back in any of these cases. This is just you pay them 5, and then this is how much you win if you get the corresponding number of baskets. And we'll also say that the probability of making any one shot, any one given shot. So I just put you up to the stand and say, okay, go. The probability it goes in is 0.3. Okay, we'll call that, so 0.3. Because it's a carnival game or a fair game, and these are always rigged. So your odds of getting it in are not very good. So expected value, this is going to be, okay, I want to find the probability of each outcome. So I want to find the probability that I get nothing in, the probability that I get 1 in, the probability I get 2, or the probability I get 3. And I want to take each of those probabilities and multiply them by their corresponding payout. So the probability I get 0 times 0, the probability I get 1 times 0.5, the probability I get 2 times $6. And then at the end, we can subtract out $5, or you can just subtract out 5 as you go. You'll get the same answer. And if I want to calculate these probabilities, then how do I do that? Hopefully you've watched the video on the binomial distribution before this, and you recognize that in this situation, I have only 2 possible outcomes for each of my individual trials. It either goes in or it does not. Additionally, those probabilities are fixed. I'm doing a set number of trials, etc. So all the conditions of a binomial distribution are being met here. So I'm going to use the binomial distribution to calculate the expected value. So the probability that I get 0 baskets in is equal to 3 choose 0 times 0.7 to the 3rd power times 0.3 to the 0. Probability of getting 1 is 3 choose 1, 0.7 to the 2, 0.3 to the 1. Probability of 2 is 3 choose 2, 0.7 to the 1, 0.3 squared. And the probability of getting all three is 3 choose 3 times 0.7 to the 0 times 0.3 to the third. So this is going to give me 1 times 0.343. Since 1 is what 3 choose 0 is, 3 choose 1 is 3, and that's going to be multiplied by 0.441. Then I'm going to do 3 times 0.189. And 1 times 0.027. And that gives me 0.343, 0.441. Oops. Sorry, I think I wrote the wrong thing here. This is not 0.441. That number is actually 0.147. And the same thing with the one below it. I just looked at the wrong column in my notes. This should be 0.063. Sorry about that. So then we multiply, you get 0.189 and 0.027. So these are the probabilities, okay? But what I need to do now is I need to take each of those probabilities and I need to multiply them by the payouts. So what is the payout? So I'm going to multiply by my first payout is I've lost $5, right? I win nothing, so I lose $5, so negative $5. Next one, I lose $4.50, so negative $4.50. Next one, I win $1, because if I win 6 and I paid 5, I'm going up by 1. And in the last case, I'm winning $20. So now I'm going to take these and I'm going to multiply this. I'm going to multiply these. I'm going to multiply these, multiply these. When I do all of that, what I end up getting is I get, so for 0, 1, 2, and 3, I get negative $1 and we'll say 715 cents. You can't really have that, but whatever. Negative 1.9845. We'll round at the very end to cents. For now, we're going to keep it to try to make sure our final answer is as accurate as possible. And then I get 0.189. And I get 54 cents. And when I add all these up, I get negative $2 and rounding 97 cents. So what this means is that I'm losing almost $3 every time I play this game. So this is not a game that I would want to play. Additionally, you can think of games generally as being either fair or unfair. A fair game is a game where both players have an expected value of 0, right? One player is not favored to win over the other one. So this is an example of an unfair game because the carnival or the fair, whoever is running this game, is favored to win it over the player. Most games that you encounter in settings like that, in casinos, lotteries, carnivals, fairs, the theme parks, are all unfair games. When you play, you are playing knowing that you, on average, will lose. Doesn't mean you'll lose every time, but if you play the game a large number of times, if I play this game, let's say 100 times, then how much do I expect to lose? Well, I expect to lose this times 100. So after 100 times playing, on average, I'll lose $297. So not great, not great. And that is how expected value works. Thanks for watching.